The leave plan of room specialists has found that using our new 101 billion toy, it will be apparently everlastingly before that try changes into a reality. On the remote possibility that it goes as arranged, the outing to Proxima B will expect near 20 years. So, sensibly, it will be several years earlier we can expect if there is certain life on that planet. The de-established sales of whether we are really alone in this universe perseveres through. The James Webb Telescope has discovered some incredibly humanesque things far away from Earth that lead us nearer to the response. Our mission for life beyond us has been uncontrolled throughout every human action to such an extent that we have countless media works and speculations concerning this matter. Our wonder concerning our spot and significance in the universe has been reliable. It is pervaded inside us to reliably search for a mate, despite how similar we might be. We might get progressively nearer to the responses we really need. How, anyway, are they really the answers we are looking for? Or are they simply really upsetting? Join us as we dissect the most progressive discoveries in the space of systems and planets on the journey to track down something we likely won't be prepared to see. Lights far away. Experts have found what could be the most significant revelation in history back in 2021 when the James Webb Space Telescope was planned to launch. An exceptionally intriguing hypothetical request was raised about the capabilities of our technology. The question was whether, later on, our telescopes could detect artificial light on another planet, for instance Proxima B, the nearest exoplanet to Earth. Proxima B, around 4.25 light-years away, was recognized to be perfectly locked with a very long-lasting day side and night side like our moon. A hypothetical, imaginative enhancement for Proxima B could move power and energy from the day side to the night side utilizing photovoltaic cells that make power from starlight. Subsequently, in a paper with Manis Vling as one of the researchers, it was shown that an epic convergence of the day side by solar chargers could be associated with future telescopes. Since the JWST was further developed, it would allow us to expand our search for artificial lights on exoplanets like Proxima B. Now, the fact that the James Webb Space Telescope did exactly that in 2024, using its higher mindfulness and greater degree of capacities, is groundbreaking. The JWST might have tracked down the lights we were searching for and maybe flung us into another huge surge of human action. Overall, we should dive into the universe of planets and exoplanets to figure out how this was, without a doubt, even possible. James Webb's mission researches Proxima B and Proxima B's mysteries. Starting from the outset of written history, individuals have contemplated the chance of the universe, what we are, where we come from, and where we go. These are traditional yet surprisingly inconvenient solicitations that humankind has tried to answer. When we acquired awareness in the hour of fantastic mechanical improvement, one wonders whether we are any closer to taking note of these questions. If you somehow manage to ask a philosopher, he could say we are currently at level 0 of understanding ourselves in the universe. In any case, ask a space expert the same question and watch him take full advantage of his energy as he rushes to tell you the latest discovery individuals have made about the universe using their advanced gadgets. These instruments, yet not given a lot of thought by the general public, are directly an impression of human movement itself. We now have the world promptly open, and it's time we push forward and get the universe at our fingertips too. One such technique for doing so is determined by analysts and space experts through the innovation we tackle. A specific making of that innovation is now capable for the new discovery of what might be light on another planet light-years away. Indeed, we're discussing the James Webb Space Telescope. The James Webb Space Telescope is the creation considered out of the customs of human endeavors into space to address some ever-present questions. Are we alone? Who's out there? Where do we start and where do we end? This infrared space science gadget has already started looking out for these questions. Not enduring the reality that at first you could get yourself asking what Proxima B is. Proxima Centauri B, or just Proxima B, is sometimes referred to as Alpha Centauri SE. It is a super-Earth exoplanet and orbits an M-type star. Super-Earths could baffle you, but don't worry. This text will settle all your consuming inquiries. Super-Earths are a class of planets that are more monstrous than Earth, however lighter than ice giants like Neptune and Uranus. They are truly one of a kind, and they can be made of gas, rock, or even a blend of both. Moreover, their sizes can change from twice the size of Earth to several times its mass. With respect to B, it is a super-Earth and an exoplanet, meaning that a planet orbits outside the nearby planetary system. The primary possible proof of an exoplanet was found as early as 1917, although it sparked little interest. However, confirmation came in 1992 with the first confirmed discovery, which left specialists paralyzed. Another exoplanet first identified in 1988 was confirmed in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems. Of these, 896 systems have more than one planet. These famous discoveries are surrounding an M-type star. To understand the M-type star, you really need to sort out the red dwarf. A red dwarf is the smallest kind of star in the main sequence, hence the name. In the interconnecting area of the Sun, red dwarfs are by far the most common type of star found in the Milky Way. They have extraordinarily low luminosity, and since luminosity is one of our principal tools for planet discovery, red dwarfs are not easy to see. These unnoticeable stars have variable definitions and names depending on their temperatures and sizes. For instance, M dwarfs or M-type main sequence stars yield a maximum temperature of around 3000 K, hence getting their name. As for B, its mass is known to be practically identical to 1.07 Earths. Interestingly, it only takes 11.2 days to complete one orbit of its star, compared to our 365.25 days. You can measure the size of the star Proxima B is surrounding by considering the entire electromagnetic spectrum. The star has a total luminosity of as little as about 1.6% of that of the Sun. Other than in the visible light spectrum, its radiance seems to decrease more. It only shines 5 to 6% of the Sun's brilliance, radiating a much lesser amount of light energy compared to the Sun. Over 85% of its emitted energy is infrared radiation, revolving around about 0.045 to 0.056 Australian dollars from its star. Proxima B's discovery was reported back in 2016. You might ask, why is Proxima B, with millions of stars, planets, and galaxies, of such interest? Well, there are several reasons that contribute to the astronomers' interest here. Specifically, Proxima B is the closest known star to our Sun. By definition, although 4.2 light-years is a big number to us Earthlings, in the grand scheme of the universe, it is a simple blip. So why is Proxima B, our closest known star, high up on the priority list right now? It is part of the triple star system called Alpha Centauri. In addition, notwithstanding Proxima's glow being very low, the system itself appears as one of the brightest celestial bodies in the night sky, just behind two others called Sirius and Copus. Anyway, the most charming thing about Proxima Centauri B is that it could truly be livable as it falls within the habitable zone. The possibilities surrounding the star are endless, and therefore, space experts have assumed the task of exploring the depths and limits of the star's validity. Likely, that is where the James Webb Space Telescope comes in. The four main goals of the JWST are to look for light from the first stars and galaxies that formed in the universe after the Big Bang, concentrate on the universe's evolution and development, understand star and planet formation, and focus on planetary systems and the origins of life. As the JWST continues its examination of the said exoplanet, we draw closer to the pinnacle of these missions, from searching for exoplanets to looking for extraterrestrial life. So, what exactly is said, one could ask, considering that humans have always been an inquisitive species, exploring and getting into literally everything that moves and doesn't move? It makes sense that a mission like SEI appeared on such a massive scale. Imagine that God has composed an incredible, immense project, but with a touch of gold. We are endowed with being the ones keeping watch for signals, more specifically electromagnetic murmurs from human developments beyond anything we could ever imagine. SEI, short for the search for extraterrestrial intelligence, resembles the world's most high-stakes game of hide and seek, with our team as the seeker and the vast universe as the seemingly endless hiding spot. It is one of those fields where scientists are like high-level Sherlocks, tuned into radio waves and scouring for that subtle, we are not alone signal. This astronomical sleuthing started in the 1960s. Frank Drake, a prominent astrophysicist, was among the first to recognize radio transmissions from the stars. It was a remarkable moment. However, no outsiders appeared at his door, at least not yet. Looking for something this huge takes patience and can span many years of work. Sometimes, not many conclusive extraterrestrial signals have been found, notwithstanding these efforts. The excitement continues to grow as the James Webb Space Telescope keeps on examining exoplanets like Proxima B. A whole field of hope is emerging. Will we accidentally find genuine proof of extraterrestrial life? Or will we simply experience eerie signals right outside our ability to comprehend, giving us more questions than answers? The discovery of lights, in fact, could mark the next chapter of humanity's timeless pursuit, where curiosity and progress merge into one massive, exciting space story. So, let's keep looking, hoping to find confirmation that we are not truly alone. The discovery of lights from distant exoplanets like those potentially seen on Proxima B could be a significant step toward answering one of humanity's most important questions. Are we alone in the universe? As the Webb Space Telescope continues to examine the skies, its discoveries will undoubtedly spark more conversations, investigations, and perhaps challenges to our fundamental understanding of life, intelligence, and the nature of the universe. The implications of these discoveries extend far beyond simple curiosity. They carry the potential to reshape our philosophical and scientific systems. For instance, if we were to confirm that Proxima B or another exoplanet harbors some form of life, it would require us to rethink our place in the universe. Could life elsewhere evolve in ways similar to ours? Or would it present a completely new type of existence? Would it follow similar transformative paths? Or would its biology and consciousness challenge everything we know about life on Earth? Even if we fail to find direct evidence of intelligent life, the mere fact that we could detect artificial signals or lights from distant worlds would still have significant implications. It would mean that intelligent civilizations are out there, potentially capable of altering their environments in ways that are detectable from our vantage point. This would confirm that intelligent life is not an anomaly but perhaps an inevitable outcome of specific conditions in the universe. However, it's important to remain grounded and cautious in the face of such discoveries. While the potential for finding life is exhilarating, it also raises the question: what happens next? How would we respond to the confirmation of extraterrestrial life? Would we approach it with respect, curiosity, and scientific thoroughness? Or would the discoveries spark panic, fear, or even political battles? History has shown that humanity's responses to new discoveries, especially those that challenge deeply held beliefs, can be unpredictable. We should also consider the ethical aspects of our curiosity. If we do find proof of life, especially intelligent life, what does that mean for our responsibility as stewards of our own planet? What moral considerations should guide our interactions with other forms of life, whether microbial or advanced? These are not questions that can be easily answered, and they will likely be a central part of the conversation as we venture further into the universe. Nevertheless, the search for life beyond Earth, driven by instruments like the James Webb Space Telescope, represents a fascinating crossroads of science, philosophy, and humanity's future.